Okay, welcome you all for the class. Today we are going to discuss about chapter 1 of the syllabus. Here we will talk about real numbers. You have already been learned a lot about numbers till class 9. Likewise, in your class 5, you learned about natural numbers. That is starting with number 1, 2, 3 onwards. Then onwards, we included 0 along with those numbers. So you got this as 0, 1, 2, 3, 4. That is called as whole numbers. Then we expanded our group bit and we learned about integers. Okay, that is we included negative numbers with that. After that, we included making the group wider. We included different types of numbers which were not part of the previous one. That is, we were discussing here about the numbers which are not whole, incomplete. Okay, just for that the Sanskrit word is saying apurnank. Okay, what is apurnank? Apurnank, that is purna anka. That is complete number. So the numbers which are not complete, which we call them as fractions. Okay, so what about these fractions? The fractions were not part of any of these natural numbers, whole numbers, integers, right? So we described it in a different way. That is the numbers which are in the form of P by Q form. Okay, we call them as rational numbers. And our fractions are also a part of this P by Q because each fraction can be expressed with a numerator and denominator. So in general, we can say it is in the form of P by Q form, right? And that's why the rational numbers are nothing but P by Q, but the condition is both P and Q are integers, okay? And Q is a non-zero number, okay? So after that, you learned a bigger one, okay? That is about the irrational numbers, right? In this irrational numbers, what did you learn? So the numbers which are not in this P by Q form, we call them as irrational numbers, isn't it? And then combining these irrational numbers and rational numbers together, we call them as real numbers. So real numbers are in short rationals and irrationals together. Okay, so now our number, the most longest or the you can say the biggest one where you are including all the numbers are nothing but real numbers. Okay, so here we are going to discuss about real numbers, but before going to that, we go with our basic concept and connect with one of the concepts. What does it say? Okay, so in your lower classes, you learned about division of numbers. Okay, and while doing the division, means after doing the division, when you divide a number, say 25 divided by 3. So you call this number to which you are dividing, you call it as a dividend. The number to which you divide, we call it as a divisor. And when you do this division actually, okay, this is a method you used to do in the lower classes. So this number you call it as a quotient and the remainder. Similarly, if I take another example, say, you get something like this. And your number, you used to write dividend as what? So you used to write dividend as divisor into quotient plus remainder. Similarly, looking at this, so you can write 25 as 3 multiplied by 8 plus 1. Similarly here, 47 could be returned as 7 into 6 plus 5. Isn't it? So you will say yes, because this very easy concept which you have learned it in the lower classes. So what is new in it? Okay, so we call this as, see, in lower classes generally you learn many things, but the concept we learn it from here. So here, what do you call these concept as? It is derived by Euclid, and it is known as Euclid's division lemma. Okay, Euclid's division lemma. Okay, what does it say? That if there are two positive integers, say A and B, such that I take A is greater than B. Okay, there are any two positive integers A and B, and such that I take one bigger and the other smaller, then there exists. ये जो उल्टा वाला E का sign है, that shows there exists. Okay, Q and R, such that, तो ये क्या position लेंगे? When A can be expressed as PQ plus R. But then dividend is equal to divisor into quotient plus remainder, isn't it? And then what is this? A, B, your numbers, right? Q is any integer, and R for remainder actually. And what is the condition for this R? It has to be smaller than the divisor. You know that you stop the division as soon as the number which you get in down is always smaller than the divisor, isn't it? Like for example, just now I took the here, say 7 6 are 42. Okay, so remainder is 5. Suppose I had one more digit here, so 5, the 0. Then you go ahead again. Okay, if I go on putting the digit here, you will continue till you get this. Okay, smaller than this. Now compare. You will stop the division as soon as you get this smaller than this. So this is nothing but the Euclid division lemma. I hope I'm clear with this. Okay, so now what is the use of this Euclid division lemma? Basically, for exam purpose, yes, the statement could be asked. Okay. Secondly, this condition could be asked. What is the condition for the remainder? So generally, this is asked that always it is greater than or equal to 0 or lesser than and lesser than the divisor. Am I clear with this? Okay. So then we have one more application of this. Okay, which is called as Euclid's division algorithm. Why algorithm? Because using the lemma, we will follow certain steps, and those steps will help you to find out to find something. Okay, and that is what called as Euclid's division algorithm. And what will it help you? It will help you to find out the HCF of the numbers. Do you remember HCF of the numbers? Your class 5 and 6 concept. Okay, HCF, that is highest common factor, or and the other word was lowest common multiple. Okay, so you learned that with other methods. There were 2 methods to find out HCF, rather 3 methods, isn't it? That first you used to write down the common factors, right? All the factors of the numbers and then marking common, right? The second was prime factorization method. And the third one, what you learned was division method. So here first we are going to discuss the division method, which will help you to develop Euclid division algorithm. Let's see how. Okay. So I'll take one example. Say here 72 and 48. Okay, I'll just take another number because I want something where it is not divisible. Say 60. Okay. Now, so which is a smaller number? So smaller number will divide the bigger number. So 60. This will be as a working column of our part. This is not the actual part of the sum. Okay. So we'll do it as a working column here. So 60 divided by 72. So actually one is that. Oh, I'm sorry. So this is 12. 60. 5 is that. You remember the step? What you used to do it here? You take a bigger number, divide it with smaller number. What remainder you get it? Again, that number will divide the divisor of the previous number. So यानी कि previous number का जो divisor है वो यहाँ पे dividend बन जाएगा. And we continue this division till we get 0. तो यहाँ पे हमें 0 मिला है. So how will we write this using Euclid division lemma? ये आपको full form में लिखना है. I'm just using it here. Okay. So 72. तो 72 को आप यूक्लिड डिवीजन लेमा फॉलो करोगे तो कैसे लिखोगे? It is 60 into 1 plus 12. Isn't it? Then second step में, तो second step में आपने डिविडेंड किसको बना लिया? 60 को. So it is 12 into 5 plus 0. तो जब आपका 0 आ जाता है तब जो आपका डिवाइजर होगा, so what was the divisor here? 12. So this 12 is nothing but HCF of these numbers. Are you getting it? So these are the steps which you have to actually write in the exam or to solve the sum. This will help you to get this, isn't it? We'll see one more example. So I'll take 80 and 70. I'll take something which will help you to go with the longer. 48 and here 64. Okay, so here 48 will divide the bigger number 64. So 48 ones are 48. Simple. 14 minus, so it is 14 minus 8. So you get it as 6. So 60, 48. Again 3 is up, we get it. This is also ending up in 2. Okay, so we get it again. So same way, using this concept, how will you write this as? So the bigger number is 64. It could be written as 48 into 1 plus 60. Okay, again the divisor of the first is dividend. We got 0. So here, what is the HCF? It becomes 60. Okay, I hope I'm clear with it. So these are the steps which are must using Euclid division lemma. So this is one of the application of Euclid division lemma, which you have to use it and you have to practice this to solve the sum. Okay, then now let's go back to your class and load classes concept. Okay, which is also part of your class 10 syllabus and which is also very important for you to understand. What does it say? Again, going back to your low classes of your class 6, right? So especially 6, you learned about the prime and the composite numbers, right? What are the prime numbers? You have learned it well. Prime numbers are those which have only two factors, 1 and the number itself, isn't it? 1 and the number itself. जिसके पास सिर्फ दो factors हैं, तो उसको हम क्या कहते हैं? Prime number, right? And composite number is simply opposite of it. Okay, so prime with two factors, 1 and number itself. Okay, और जब मैं composite कहूंगी तो क्या होगा? Simple सी definition है इसका opposite, यानी कि greater than two factors. मतलब those numbers which has more than two factors, we call them as composite numbers, right? Okay, तो ये composite number का factorization आपने सीखा, उसमें आपने एक चीज भी सीखी, that you remember the chain method, tree method, factor method. जैसे कि 72 के factors हैं, तो suppose 8 and 9. Further, if I ask you that, okay, what are the factors here? And then here, so naturally, so this will go up to prime factorization. Okay, so this is also one of the concepts you have learned it before to find out the factorization of the number, right? और दूसरी चीज जो आपने सीखी है composite number का, that is HCF and LCM. तो यहाँ पे जो मैंने word use किया prime, okay, तो ये चीज आपको factorization में help करती है. Now see, multiplication and factorization, they are reverse concept of each other. ठीक है, जब आप दो numbers को multiply करते हो तो उसकी product होती है. Okay, means when you multiply two numbers, you get its product. And when you factorize product, you get those two numbers, or more than two numbers rather. Okay, so यहाँ पे आपको देखना है, we were discussing about prime numbers. Okay, तो prime factorization मतलब क्या है? तो आपको numbers के सारे factors निकालते हैं और वो सारे factors prime numbers होने चाहिए. So that is called as prime factorization, which is already learned by you in the lower classes. तो जैसे अभी हमने दो एग्जाम्पल लिए थे, मैं उसी टाइप के नंबर्स ले रही हूँ. तो सपोज हमें 72 और 60 का HCF फाइंड करना है. फर्स्ट ऑफ ऑल प्राइम फैक्टराइजेशन में आपने क्या सीखा? यू विल फैक्टराइज दिस नंबर, राइट? 60, then it is 2 into 2, 4, 3 are 12, 5 are. तो आपका HCF क्या कहता है? HCF is nothing but your common factors, isn't it? तो आपका HCF इसमें क्या होगा? क्या है कॉमन? 1, 2 and this. So this is nothing but 2 into 2 into 3. That is HCF is 12. And what is your LCM here? You're familiar with this concept then? What is LCM? LCM is common factor into uncommon factor. तो ये हमारा जो common factor है 12, मतलब कि HCF into uncommon factors. तो कौन-कौन से uncommon factor है जो बच्चे हैं वो सारे ले लीजिए. So into 2 into 3 into 5. Okay. So 12 5 are 60, 60, 3 are 90, 2 are 150. So this is the way we find out HCF and LCM of the by prime factorization. ये आपने already पहले सीखा हुआ है, but yes, this is the part of your class 10th chapter 1 syllabus. Okay, so easy for you to score it. तो ये सम से आपको याद रखना, isn't it? So you will try to practice similar kind of questions. Okay. अब इसमें एक आगे आता है जो एक कॉन्सेप्ट आपका है, ओके, एक और जो कॉन्सेप्ट है आपका which is called this property. अब जैसे मैं यहाँ पे ही कर रही हूँ, ठीक है, मैं 72 into 60 को मल्टीप्लाई कर रही हूँ और 12 into 180 को मल्टीप्लाई कर रही हूँ. Okay, let's see what I was getting. Okay, so 72 6 are 12, 42, 432 and the 0. So we get this as 432 0. Okay. And now look at this 12 into 18. So 2 8 are 16. Okay. Am I wrong with this something? Oh, I'm so sorry. This is 360, isn't it? This is 360. Okay. So here 12 into 360. So something like 144 threes are. Okay. I'm 0. 2. 4 threes are 12 and 3. 1 carry 4 3 2 0. So what did you notice? Okay. It means if I multiply these two numbers and if I multiply HCF and LCM, then it's same. Okay. So this is one of the formula which you did solve in your lower classes. What does it say? HCF multiplied by LCM is equal to product of two numbers. मतलब क्या कहता है कि when you multiply HCF and LCM, it will always be equal to product of two numbers. So okay, this is one of the common question which comes in the exam. Okay, you are given the two numbers, so they will say that find HCF and LCM and verify this property. तो जब verify करना तो आपको यहाँ पे ध्यान रखना है, okay, कि आपको पहले HCF फाइंड करना है, पहले LCM फाइंड करना है, फिर आपको दो नंबर्स लेके मल्टीप्लाई करने हैं, फिर उसको HCF और LCM मल्टीप्लाई करना है, and then you will say yes from 1 and 2 we can conclude that this into this. एक साथ equal to sign में follow नहीं करना है. Please remember this. Okay. So here this comes as 2 to 3 marks. Isn't it scoring for you? Because this is your low class concept. Just a revision of it. Fine. Okay. So I move on to the next one. और या तो दूसरा इसमें okay one more time. इसका और एक application कैसे आता है? यही question को दोबारा कैसे मतलब the other way of asking is like you will be given with HCF and LCM and you will be given with one of the number and you will be asked to find the other number. तो आपके पास ये एक ही formula जो आपको help करता है find out this. मतलब HCF लिखेंगे, LCM लिखेंगे and one of the number is given here. So you bring that here down, divide it, so you get the other number. I hope I am very clear with it. Like for example, हमें दिया है say 72 दिया हुआ है, HCF हमें दिया हुआ है say 12, okay, LCM हमें दिया हुआ है 360, हमें पूछा है कि second number कौन सा है. Like this is the question. We use this HCF into LCM is equal to product. Okay, तो यहाँ पे मैं लिखूंगी 12, 360, 72 multiply by हमारा second number. तो second number क्या हो जाएगा? 12 into 360 is 72 को यहाँ लाएंगे हम, isn't it? So second number. तो क्या हो जाएगा? 12 ones are 12 six are 6 ones are 60 are. So our second number is 60. Isn't it the same? Okay. So anyway, they ask you the question. Either they tell you to find out HCF, LCM, and they ask you to verify the property, or they give two numbers and one of the number and HCF or LCM, and they ask you to verify the property. So anyway, the question can be asked to you. So I hope it is one of the easier one for you to score it. Okay. And now let's move on quickly for same concept, okay, but with different numbers. Okay, what different type of numbers? They are exactly not even numbers. We are going to forward with algebraic part. Okay, so we have the same number here, but it has to be done it in a different way. अब इसमें क्या करना है? You will be asked to find out HCF and LCM, but यहाँ हमें numbers नहीं दिए हुए, यहाँ हमें दिए हैं algebraic form में. So how is it? Just quickly look at it. और या तो हमें दिए होंगे numbers in the exponent form. So how do you do it? Suppose if I tell you x cube y square and say x square y raised to 4. These are the two numbers. अब इसका HCF और LCM आपको find करना है. तो कैसे करेंगे वो देखिए. तो x cube into y square. तो जनरली आप क्या करेंगे? आप ऐसे लिखेंगे. Okay? Isn't it too boring to write? Okay. So फिर भी देख लेते हैं एक बार. So HCF, isn't it? So HCF क्या आया हमारा? जो कॉमन है दोनों में कॉमन होगा. So x into x, y into y. So x square, y square आपका बन जाता है HCF. और LCM क्या बनेगा? कॉमन into अनकॉमन. तो कॉमन आपका क्या था? x square y square into अनकॉमन. तो अनकॉमन में यहाँ पे क्या बच रहा है? एक x बच रहा है. ओके, और यहाँ पे क्या बच रहा है? y into y one more. तो दो y बच रहे हैं यहाँ पे. So it is x cube into y raised to 4. This is the way to find it out. But हम इतना सारा नहीं करेंगे. There is a shorter way. तो क्या करना है? Simple. Look at the numbers. I mean, look at the powers of the numbers. Right? तो हमें यहाँ पे क्या दिया? X cube y square और x square y raised to 4. ठीक है? तो पहले x पे फोकस करते हैं. यहाँ पे x का पावर क्या है? 3 और यहाँ पे x का पावर क्या है? 2. ठीक है, तो हमेशा जब HCF होगा वो छोटे वाले पावर को आप सिलेक्ट करोगे. HCF मींस कॉमन. ठीक है, तो कॉमन क्या होगा? तो जो छोटा पावर होगा दोनों के पास होगा. तो HCF इज ऑलवेज प्रोडक्ट ऑफ कॉमन फैक्टर्स. समझ में आ रहा है? HCF इज अ प्रोडक्ट ऑफ कॉमन फैक्टर्स और LCM होगा वो हमेशा हाईएस्ट फैक्टर लगेगा. देखिए कितना इजी हो गया. तो डायरेक्टली HCF छोटा वाला कौन सा है? x स्क्वायर. फिर y raised to 4 and y square छोटा वाला कौन सा है? y square. LCM highest वाला x cube and x cube. Highest. Is it easy? It's a very simple. So similar kind of questions you can prepare. One more with the numbers. Suppose you have given the 2 into say 7 raised to 4 into y raised to 5 and यहाँ पे आपको दिया है 2 raised to 4 into 7 into y cube. Okay, अब आपको इसका HCF फाइंड करना है. So very quickly, the same thing. HCF क्या होगा? The smaller part. The smaller part, cube. Smaller part, 7. Smaller part, y cube. LCM, higher part. ठीक है, यहाँ हम आपको इसको सॉल्व करने आपको नहीं बैठना है. You are given the answer with the part form, तो आपको उसी में उसको लिखना है. Isn't it easier for you to understand? Right? Okay. And एक लास्ट कॉन्सेप्ट जो मैं लेना चाहती हूँ यहाँ पे साथ में. तो looking at the numbers when the numbers are given in exponent form, आप सिर्फ numbers देख के आप क्विकली उसको आंसर कर सकते हो कि HCF क्या है, LCM क्या है. और उसी तरीके से डायरेक्ट आंसर आप दे सकते हो को प्राइम नंबर्स पे. अब हमने अभी डिस्कस किया प्राइम नंबर्स, कंपोजिट नंबर्स. सो व्हाट आर दीस को प्राइम नंबर्स? देखो. ओके, ये को प्राइम्स यहाँ पे क्या है? What are these co-primes? So co, that is relatively prime. Simple. Relatively prime. अब relatively prime का मतलब भी क्या हुआ? Okay, what does it say? Relatively prime या co-prime का मतलब क्या होगा? That when two or more numbers. Okay, when you compare them, when two or more numbers, when they have nothing common between them except one. इसका मतलब कि जो कोई भी दो नंबर जब आप लो और उनके बीच में सिर्फ कॉमन फैक्टर वन हो, ठीक है, कॉमन फैक्टर वन हो, तो उस नंबर्स को हम कहेंगे को प्राइम नंबर्स. ओके, आई एम रिपीटिंग इट विद द एग्जांपल. आप कोई भी नजदीक वाले नंबर लीजिए, कंसेक्यूटिव नंबर्स. आई होप यू नो व्हाट आर कंसेक्यूटिव. एक के बाद एक. 15 एंड 16. सी, दोनों कॉम्पोजिट नंबर्स हैं, राइट? दोनों के फैक्टर्स दो से ज्यादा है, बट फिर भी इसको को प्राइम क्यों कहते हैं? क्योंकि इन दोनों को जब हम साथ में लेते हैं तो इनके बीच में कुछ भी कॉमन नंबर है नहीं. द ओनली कॉमन फैक्टर इज वन. And that's why we call them as co-prime numbers. Suppose I take the example of 18 and 21. Okay, will you call them as co-prime numbers? Let's see. इन दोनों के बीच में कुछ भी कॉमन है तो है. इसमें 3 कॉमन है other than 1. और इसलिए हम इसको co-prime में कंसीडर नहीं करेंगे. और if I say here, say 16 and suppose 21. So 16 के भी फैक्टर्स हैं, 21 के भी फैक्टर्स हैं. बट जब 16 और 21 को साथ में लेते हो तो उन दोनों के बीच में कॉमन क्या है? कुछ भी नहीं एक्सेप्ट वन. एंड दैट्स व्हाई वी कॉल देम एज को प्राइम नंबर्स. ओके, अब इसका शॉर्टकट क्या है? ठीक है, तो अब सपोज आपको इस तरीके के नंबर्स दिए, ओके, को प्राइम नंबर्स, और आपको कहा कि फाइंड आउट HCF एंड LCM. तो कैसे डायरेक्ट करेंगे? कोई मेथड नहीं, नो फैक्टराइजेशन, नथिंग. डायरेक्टली इसका HCF क्या होगा? तो क्योंकि आपको पता है अभी मैंने क्या बताया, द कॉमन फैक्टर इज 1. So naturally HCF is always 1. Okay, so remember this, HCF of prime number is always 1. Simple. मतलब देखा कॉमन फैक्टर है नहीं है, that means 1 is a common factor and hence HCF is 1. तो अब इनका LCM क्या होगा? क्योंकि फॉर्मूला याद है, दोनों नंबर के मल्टीप्लिकेशन बराबर HCF into LCM होना चाहिए. तो सिंपल, ये तो 1 ही है, तो हमारे लिए LCM क्या होगा? प्रोडक्ट ऑफ टू नंबर्स. तो जब भी आपको इस टाइप के क्वेश्चंस आते हैं, ये दोनों के बीच में कुछ भी नहीं है. सपोज आई आस्क यू P and Q. ओके, कोई नंबर्स नहीं है, अलजेब्रिक फॉर्म में दिया हुआ है. P and Q are two co-prime numbers. What is the HCF? तो डायरेक्टली HCF is 1. And what is LCM? तो LCM क्या होगा? हमेशा इन दोनों नंबर की product. Simple to understand. I hope I'm very clear with this. So today we discuss about what are real numbers, then going for Euclid's division lemma, right? Then using Euclid division lemma, we talked about Euclid division algorithm to find out HCF of two numbers, then HCF and LCM by prime factorization method. Okay. Then when the numbers are given in prime exponent form, how to find out HCF and LCM. Then concept of co-prime numbers, right? And to find HCF and LCM of co-prime numbers, right? So I hope that I'm very clear with it. Thank you, children. And for this, continue, look at the worksheet part of it so you get the revision of this. Thank you.